Assalamu alaikum wa rahmatullahi wa barakatuh. Dear student of first secondary, we are going to solve questions for April exam. Okay, we have different items that we are going to discuss according to the Ministry of Education models. Okay, let's start with our first question. Okay, question number 1 says that if the temperature of 0.5 mole of pure water rises by 2 degrees Celsius, the quantity of heat in calorie is. Okay, we have the temperature of 1 or 0.5 mole of pure water. Okay, we have here the atomic mass of oxygen and hydrogen. At first we will get the mass of water. We have to get it at first. Okay, so we want to get the quantity of heat, Q equal mc delta T. Okay, we have the temperature here 2 degrees Celsius, and we have the pure water, so it's a specific heat, it's a quantity that fixed, and we have to solve it 4.18 degrees Celsius. Okay, 4.18, and we have the mole that we wanted to get the mass, so we have the mole. Okay, number of moles equal mass over molar mass. Okay, we will get at the first the molar mass, and we will get half mole, so we will get the mass from it. Okay, at first we have the molar mass of water. Molar mass of water H2O equal 2 times 1, 2 atoms of hydrogen plus 16, so it will be 18 gram per mole. After that we will take half mole equal 9 gram. Okay, this is the first step. Second one, we will calculate the rule QB equal MC delta T. M have the mass 9 time 4.18 belongs to water time to that changes of the temperature as it rises, so it will be in the positive sign, so it will give 75.24 joule. Okay, we didn't want the unit joule, we wanted to get the unit in calorie. Okay, so if we have the unit we wanted to get in calorie, we will divide the number that we get in joule divided 4.18 also. Okay, so after that we will take Q equal 75.24 divided 4.18, and we will get at the end 18 calorie. Okay, so the right answer will be letter B, 18 calorie. Okay, I think it's easy question. Let's start and going to question number 2. Okay, question number 2 says that system contains two substances A and B. The change in energy for both of them is as shown in the following table. We have substance A and substance B. The change in energy in kilojoule means that we have what? We have the QB, change in energy, that will opposite to the delta H, okay, or heat content. So we have QB opposite to delta H at the first. Okay, if we have substance A and its change in energy negative 60, so it will be absorb energy from surrounding. So A QB here equal 60 negative 60 kilojoule. So delta H of or heat content of the substance A equal plus 60, and we will reverse its sign, will be plus 60 kilojoule. So it's absorb energy from surrounding. Okay, another point we have, so here the heat is lost from surrounding by amount negative 60 kilojoule. Surrounding will give the substance A negative 60 kilojoule. Okay, so the temperature of surrounding will decreases. Okay, or the energy of surrounding will decreases by amount negative 60 kilojoule. Okay, substance B here we have QB of it equal plus 40, so delta H of it equal or heat content will be negative 40 kilojoule. Okay, so that release energy to surrounding. Okay, what do you think about this? We have substance that take from surrounding 60 and also substance release to surrounding 40. What do you think about this? This means that also the surrounding lose 20 kilojoule. The surrounded lose what? Surrounding lose 20 kilojoule. Okay, it is the difference between the two substances. Okay, here, so heat is given to surrounding what? By plus 40 kilojoule. Okay, this is the substance B. So the change in energy for the surrounding at the end, there is the difference between the two substances will be plus 20 kilojoule. Okay, as it will be in the what? In the opposite sign to the system. Okay, as we said that the difference between them will be 20, and the surrounding lose also what? The surrounding lose 20 kilojoule, so it will be the change in energy in the positive sign, so it will be the right answer, letter A, plus 20 kilojoule, plus 20 kilojoule. Okay, let's going to question 3. Question 3 says that the following table illustrate the specific heat of some elements in joule per gram degree Celsius. Okay, we have 4 substances. It is the famous questions for us. Okay, we have the aluminium, copper, iron, and carbon. We have each one has specific heat. They have equal masses, okay, of this element, and they exposed to the same quantity of heat. So we have the two factors, temperature and mass constant. So the factors that will be affected by rising temperature here will be what? Will be specific heat of each substance. We said that type of substance, it is only the factor that affect the Q, or the quantity of heat that want to get at the end of a reaction. The element whose temperature rises faster is, okay, if we said that, we have a general knowledge that we say increase or decrease in temperature inversely proportional with specific heat. Okay, so if we have substance that has low specific heat, so it rises quickly and get energy very easy and increase with high temperature. So substance with low specific heat absorb heat quickly, and so its temperature increases faster. So the one that has low specific heat will be what? Will be copper. We have copper with a specific heat 0.38, so the right answer will be letter C, with specific heat, with the least specific heat here, as they absorb heat with less amount or less time and quickly, as we said that it absorb heat quickly and lose heat also quickly with small specific heat. Okay, let's go into question 4. Question 4 says that a system contains 5 grams of substance A dissolved in 30 grams of water. In the end of experiment, the temperature decreased by 3 degrees Celsius and the mass of solution was 35 grams for this system. Okay, at first we will have, at the beginning of reaction, we have 5 grams of substance A and also water 30 grams. So the summation of them will be 35. At the end of reaction, also the mass constant will be 35 also gram. Okay, so the mass here is constant. Okay, and we have here that temperature at the end of reaction decreased by 3 degrees Celsius. So the temperature or the energy also it will change it. Energy is only changed, okay, not the mass. So the factor that affecting it will be 1. So mass doesn't change, but energy changes. As we say that we have the mass constant 35 gram, So if the mass constant but temperature decreases by 3 degrees Celsius, so energy only changes, not the mass. So that it will be closed system. What kind of system? We have choices here. Both and mass and energy are changes, or closed system, open system, both mass and energy are not changes. No, the first and last here not the answer. And we have closed and open. Closed and open. Closed means that only heat or energy changes but mass constant. Open means that mass and energy will be changed. So we have here the right answer will be letter B, closed system, as only temperature or energy will be changed. Let's going to question 5. We have question 5 here, says that if we have the temperature of 1 of 34 gram of platinum raised by 5 degrees Celsius. If you know that the specific heat of platinum is 0.133 joule per gram degree Celsius, the amount of gained heat is, okay, so it will be with calculating the rule Q equal MC delta T. It's an easy question. QB equal MC delta T. Mass we have here direct 34 time specific heat we have 0.133 joule per gram degree Celsius time change in temperature is 5. Okay, we have here the right answer will be QB equal 22.6 joule. I think it's direct question here with calculating only, and you have must don't forget that your calculator in the exam. Okay, so let's go to question 6. Okay, I think the questions of the graphs, it's one of the very important questions that we have. Which of the following shapes express the right graphical relationship between the average of speed of the molecules and the temperature? Okay, we want to know the speed of molecules. What is the relation between the speed of molecules and temperature? By increasing temperature, there is a direct relation with the speed of molecules. With increasing temperature, the molecules speed or motion increase, so it's a direct relation, so it's a direct relation between them. Okay, if we have the increasing temperature, so energy increases and the average speed of molecule increasing. Okay, and it is that direct relation. So if we have the graphs, graph A, B and D will be wrong, but the right one will be letter C with a direct relation. By increasing temperature, the average speed of molecule will be increases. Okay, so the right answer will be letter C. Let's going to question 7. Okay, question 7 says that it's nearer to question 6, but we talk about 1 gram of hydrogen gas reacted as in the following reaction. H2 gas plus Cl2 gas will give 2HCl gas plus 185 kilojoule. Okay, as we said that we have the diagram that represent this reaction. Okay, if we said that we will make make a reaction, it will form a bond at the end of reaction, so it will release energy and the heat of product greater than the heat of reactant. So we have shape A and B will be wrong, at all, as the we get energy at the end of reaction or heat of product greater than the heat of reactant. It is the first one. So if we have the reaction H2 plus Cl2, and if we put 2HCl and delta H will be with delta H alone without the equation will be equal negative 185 kilojoule. So the reaction will be exothermic reaction. So the reaction will be exothermic reaction. But we have here the relation between heat content, not heat content. He want the standard heat content, delta H naught. Delta H naught means that the standard heat of or the standard heat content means that it's a constant pressure and temperature. Constant pressure 0 degrees Celsius and constant temperature 25 degrees Celsius. Okay, so we have to get the standard heat content, means that we have to get the ideal for it. Ideal for it means that we get 1 mole for a substance, 1 mole from the substance, that will get the standard heat content at 0 degree Celsius, at 25 degrees Celsius, and 0 atmospheric pressure. Okay, so we have here the reaction that gives negative 185 kilojoule. Okay, we want to get the standard. We have here 2 moles of hydrogen chloride or HCl gas, so we want the 1 mole only of HCl, okay, of the product delta H of 1, or delta H naught or standard for 1 mole of substance. So we will dividing the delta H divided 2. So delta H equal negative 185 divided 2. So the right answer will be negative 92.5. We have here the heat content of the product. So we didn't take D, but we take C, shape C, as we see that we have delta H naught will be negative 92.5 kilojoule per mole. Okay, so the right answer will be shape C. Okay, let's go into question 8. Question 8 says that the energy chart in front of you express the following reaction. It is the reaction between heat content and progress of reaction. We have the reaction that, or the substance take energy to make the reaction. So the reactant not have an energy but take energy to make the reaction. So heat of reactant will be greater than the heat of product. Heat of reactant will be greater than the heat of product. If we have substance A and B to produce C, so it will not produce energy, it will give energy. So energy will be what? Or energy will be on the side of AB, not evolving at the end of reaction. So will be the first one will be wrong. Second one, here we have reactant energy increases. We have the energy that we give to the reactant. Okay, if we have two choices, B and C, we have plus and negative. Okay, we didn't put any negative sign in the equation as we adding the substance or adding energy to the reaction, so it will not be in the negative sign, or we didn't put at all negative sign in the reaction. If we can put, or if we want to put negative, we will put it at the end of reaction away from the reaction, and we can write it delta H equal the number. Okay, so C is a wrong one. And the last one, we didn't get energy at the end of reaction, also it is equal A, but we have the delta H alone, negative 60 kilojoule. So A and D are the same, but we have the right answer will be, what will be, reaction is endothermic. Endothermic, that we take energy or give energy that increases to form the product at the end of reaction, increases to form the product, and so it will give energy to form the product. So delta H will be positive sign, and we will have A plus B plus 50 kilojoule to give the substance C as a product. So the reaction will be endothermic reaction, need energy to activate it. Okay, let's go to question 9. Question 9 says that from the reaction have H2 gas plus have I2 gas plus 26 kilojoule that give HI gas. Okay, the value of delta H in the following reaction is, okay, we will reverse the reaction. At first, if we have the quantity of heat here inside the reaction, so it will be what? It will be giving to the reaction to form the product. But here we will reverse the reaction to get delta H value. To get delta H value, okay, we have half Hg plus half I2 give Hg Hi gas. So delta H will be plus 26 kilojoule. Okay, so if we want to get the reverse for this equation, we will have 2Hi that will decompose to give what? To give H2 gas and I2 gas. So it will be at the end of reaction, we have here what? We have here 1 mole of Hi to produce it plus 26. Okay, when we reverse it, it will release, but we have 2 moles, so we will multiply time 2. So we have the product here, it will release energy as it break bond at the end of reaction, so we will reverse the sign. So we have 2 moles of Hi will be minus 26 times 2, and it will give negative 52 kilojoule per mole. Okay, so the right answer will be letter A. Okay, let's go to the last question of our exam. Okay, question 10 says that in the following reaction we have H2 plus Br2 that give 2HBr. Okay, we have the values of bond energies are shown in the table. We have the bond HH and its average bond energy that to form the bond in kilojoule per mole 436, and also bromine Br2 will be 190. Also we have the formation of HBr will be 362. So we want to know the bond energy of the reaction. We have H2, we will have H and H plus Br and Br to give to HBr. So we have the absorbed energy here and released energy here. We have 2 moles of HBr. Okay, we have 2 moles of HBr. We will okay fractionize the equation. We will have the absorbed energy, we will sum the average bond energy 436 plus 190. Okay, on the other side we will put 2x minus 2 time negative 362. Okay, 2 time means that we have 2 from this bond and it will release, so it will take the negative sign. Okay, we will calculate them. We have here plus 626 kilojoule and we have here negative 724 kilojoule. At the end of reaction, we want to get the heat content of reaction, so delta H equal plus 626 minus 724, so it will get at the end of reaction negative 98, and so it will, as we will make a broken, so we will form a new 2 moles of new product, so it will release energy and it will take a negative sign, so it is an exothermic reaction, take a sign negative 98 kilojoule per mole. So the right answer will be letter D, negative 98 kilojoule per mole. Okay, this is the last question of our exam. I hope you understand all the items that we have solved together. Okay, it is 4 April items that we have discussed. Okay, if you have any questions, please leave them below the video. Okay, I hope you good luck and goodbye.